Picture a Formula One car from 1950 next to today's machine. The difference is staggering. What started as glorified road cars with exposed wheels has evolved into aerospace engineering marvels that slice through air with surgical precision. This is the story of how Formula One discovered that mastering the invisible force of air could mean the difference between victory and defeat. From the first accidental aerodynamic discoveries to billion-dollar wind tunnels, we'll explore how the pursuit of speed transformed these racing machines into flying sculptures of science. In Formula One's early decades, aerodynamics was an afterthought. Cars were essentially powerful engines with wheels, looking more like rolling bathtubs than precision instruments. But in the late 1960s, everything changed. Jim Hall's Chaparral sports car experiments and the Lotus 49's subtle modifications began revealing air's hidden power. Engineers noticed that certain body shapes made cars faster on straights, but unstable in corners. The breakthrough came when they realized air wasn't just resistance to overcome, it was a tool to harness. Suddenly, every curve, every surface angle became crucial to performance. The 1968 season marked Formula One's aerodynamic awakening. Lotus shocked the paddock by bolting aircraft-inspired wings to their cars, creating downforce to push the car into the track for better cornering. Other teams scrambled to copy, leading to an arms race of increasingly elaborate wing designs. Cars sprouted towering appendages that looked more like airplanes than racing machines, but the pursuit of downforce came with deadly consequences. High-speed wing failures at Monza and the Nürburgring killed drivers, forcing regulations to tame the wild experimentation. The lesson was clear. Aerodynamics was powerful, but needed careful control. Colin Chapman's Lotus team discovered Formula One's greatest aerodynamic secret in 1977, ground effect. By shaping the car's underbody like an inverted wing and sealing it with flexible skirts, they could create a low-pressure zone that literally sucked the car to the track. The Lotus 78 and 79 dominated, generating massive downforce without draggy wings. Competitors were left mystified as Lotus cars cornered impossibly fast. But ground effect's power came with a price. Cars became unpredictable missiles when the seal broke. Eventually banned for safety, ground effect remained Formula One's holy grail, a perfect solution that was too dangerous to use. By the 1990s, Formula One teams realized that guesswork wouldn't win championships. They needed science. Wind tunnels became the new battleground, with teams investing millions in facilities that could test scale models with incredible precision. Adrian Newey emerged as the aerodynamic wizard, designing championship-winning cars through intuitive understanding of airflow. Meanwhile, Ferrari built billion-dollar wind tunnels, and McLaren partnered with aerospace companies. CFD computers joined the arsenal, allowing engineers to see invisible airflow patterns. Every surface, every millimeter was optimized. Formula One had become an aerospace competition disguised as motor racing. Today's Formula One cars are aerodynamic masterpieces that would make aerospace engineers jealous. Every component from front wing end plates to rear diffusers is shaped by countless hours in wind tunnels and computer simulations. The 2022 regulation changes brought back ground effect, proving that the pursuit of aerodynamic perfection never ends. As we look toward the future, active aerodynamics and AI-designed components promise even greater breakthroughs. In Formula One, the invisible force of air continues to separate champions from also-rans, making aerodynamics the sport's most crucial and fascinating battleground.